Welcome to U4L2 missing sides of similar figures. So when we know two figures are similar and we need to find a missing side length, it's actually very simple. All we have to do is use the properties of similar figures, specifically the one that says that the corresponding sides are proportional. And using that property, we can find any missing side that we need. So for example, when it says find the missing side length in the similar triangles below. Well, we know they're similar because it says they're similar, right? So it literally says in the similar triangles below. But we also have this similarity statement that is more specific about which vertices correspond, and then of course which sides correspond. So when we're trying to find the missing side length, it's notated here with a question mark. I'm going to go ahead and change that question mark to an X. And so I need to figure out what side in the other triangle corresponds to that side. The side labeled X is actually LM. So it's this side here, LM. And so if I look at my similarity statement, okay, L and M are the first two vertices in the first triangle. So the first two vertices in the second triangle are ST. So that means that if I go to the other triangle where ST is, so that's this side that's labeled 15, that must correspond with the missing side that we're looking for, which I called X. Similarly, if we're looking at MK, for example, if we're looking at MK, this side here, then what corresponds with MK, so MK is the first and third, is going to be the first and third in the other triangle, which is SU. And so that's going to be down here, it's going to be 9. Okay, and now we create our proportion, so you need to be consistent. We have a bigger triangle, we have a smaller triangle. Make sure you're consistent. I'm going to go ahead and do bigger over smaller. I'm going to do that for the entire time I'm creating this proportion, okay? So first thing I'm going to start with is X in my bigger triangle, and that corresponds with 15 in my smaller. So I'll do X over 15. And that must equal to the ratio in the same order. So I need to do bigger over smaller again. So I need to do 21 over 9 this time. So X over 15 equals 21 over 9. Verify that everything in the top comes from the same triangle. In this case, the bigger triangle, and it does, and then the same for the bottom. Now I can cross multiply and solve, so you're going to want your calculator to do this more quickly. Cross multiply and solve. I'm going to do 15 times 21. That'll give me 315 equals to 9 times X, which is 9X. Divide both sides by 9, and you are going to get 35. X equals 35. But recall that X was something that I wrote because I didn't want to use a question mark. So I'm not actually going to use this X in my final answer. I'm going to use the value that X stands for, which is this length LM. So my final answer is going to have LM equals 35. Okay, that one's done. Let's take a look at example 2. Example 2 says find the missing side length in the similar triangles below. Well, in this case, it's a little different because as you can see, we have a triangle in a triangle and there is no similarity statement here. That's because we don't need one. We know they're similar, okay? And what we can look at is the corresponding sides because they're going to be in the same position as one another. For example, if I'm looking at 40, right, ST, the side that corresponds with it is in the same position. So if I look at what that would be if this smaller triangle were to grow, okay, this ST would become this GH. So these two sides correspond, for example. Similarly, you could look at FS, and that would correspond to FG. Okay, so 55 at 99. And then same thing for FT and FH. Okay, so now we know we have to use FT because that's the missing side length, okay? So we know we have to use FT, and FT corresponds with FH, so that's 81. And then we can either use 40 and 72 or 55 and 99. It doesn't matter as long as you use one of them and you are consistent with the way that you write your ratios. So I'm going to go ahead and use 40 and 72 in this case. I'm going to do the bigger over smaller triangle again. So the bigger triangle, whenever it's a triangle and a triangle, that's always going to be these outside numbers, right? And the smaller triangle numbers are these ones inside. Okay, so the smaller triangle is inside, and then the bigger triangle is going to be outside. All right, so bigger triangle. So let's do 81 over X equals, and then that'll be 72 over 40. So just make sure that the numbers on top all came from the bigger triangle, 72 and 81, and that looks good. And then X and 40 are in the smaller one as well. Cross multiply and solve. So we're going to cross multiply and solve. 72X equals 81 times 40, which is 3240. And then we divide both sides by 72. We end up with X is equal to 45. I am doing all this work in the calculator just to make it faster. And then it's not really X, right? That length we're looking for is FT. So we're going to write that FT equals 45. All right, next, for example, 3, it says find the missing side length in the similar triangles below, shown below. So same thing. This time we do have our similarity statement again, so we want to utilize that. We don't want to guess what sides correspond. We want to use that statement. So first things first, the one I need to find is RU. That's this one with the question mark. So I know I need to use RU. RU, that's going to be the first 2 vertices, so that's going to correspond with UV. And UV is going to be this side 48 right here. Okay, UV is going to be this side 48. And then you can always double check, but that means the other 2 must correspond because we only have 1 more of each side in each triangle labeled, right? So 7 and 42. And be consistent. This time I'm going to do small over big just because it doesn't matter. I'm just going to be consistent. So I'm going to do the smaller over the bigger. So for example, if I do a ratio of x to 48, so x to 48, that has to equal the ratio of 7 to 42. You have to go back and start with the small triangle again. Okay, so 7 to 42. Make sure everything on the top came from the same triangle, and it did. Same thing on the bottom. Everything on the bottom of the fraction, sorry, came from the same triangle, and it did. Okay, cross multiply and solve. So we have 48 times 7, so 48 times 7 is 336. Is equal to 42x. Divide both sides by 42. And we end up with 8. So x is 8, but it's not really x. Remember, it is this length from R to U, so we'll use RU. So RU equals 8. All right, I would try example 4 before watching the video, and then you can always pause it while you try it, and then play the video to check and make sure you got the right answer. Okay, so for example 4, hopefully you found that you're looking for GV. I'll call that X. And GV corresponds with GF. And so that's 48. And then 96 and 60 are also going to correspond. So for example, you could have 96 over 60 is equal to, and then 48 over X. You need to make sure that these are from the same triangle, and they are. Okay, and now we can cross multiply and solve. You could also have these fractions upside down, right? But you need to have everything that corresponds in the same fraction and in the same order. So we have 96x equals 48 times 60, 2880, divide by 96 on both sides. And we do get 30. But again, it's not x, it's actually this missing value here from G to V. So GV is 30. Okay, now I do have one more thing that I want to show you guys, and it's a special type of proportion that we can create specifically. So let's look at the side splitter theorem. So the side splitter theorem says this: a line drawn parallel to any side of a triangle that intersects the other 2 sides will divide them proportionally. This is actually true for something that isn't even a triangle, as long as it could be a triangle if we kept going with the sides. And that's going to be true as well for any shape like that. Okay, so taking a look, we have these 2 parallel lines. Okay, one is the side of the triangle and one is in the triangle. And it's splitting the opposite sides here. Okay, so the side splitter theorem says that if I take the 2 portions that one side is split into and I make a ratio, so A over B, that's going to be proportional to or equal to another ratio of the portion that the other side is split into, right? In the same order. So for example, since A is the top portion, then C would be in the same position as A. So C would be in the top of our fraction. And then D would be at the bottom in the denominator, and that's because D is in the same position as B. Okay, it's in the same place. Okay, so find the missing length. So if we look at this situation, we have 2 parallel lines, so we can use the side splitter theorem. So what it splits them into is 5 over 4, so I can go ahead and start with that, equals 2, and then what corresponds to 5 will be this question mark, I'll put an X there, over what corresponds with 4, which is 8. Cross multiply and solve, you end up with 4x equals 5 times 8, which is 40. Divide by 4 on both sides, and you get that x is 10. Of course, x is something we put, so I won't use x, but I also have no other way to label this. There's no vertices labeled, so the value is 10 that we're missing. All right, try the last one, and then you can pause the video while you try it, and then you can unpause it to check your work. So for example, 6, again, even though we don't see the triangle yet, if we kept going, that would be a triangle. So we can use side splitter theorem. So if we look at the sides that this is split into, we have x, I'll put x instead of question mark, over 8, x over 8 equals, that's going to be 9 over 6, 9 over 6. Ensure that the numbers in the numerator came from the same portion and the denominator came from the same portion, and they did. Now we can cross multiply and solve. We end up with 6x equals 72. Divide 6 on both sides, divide by 6 on both sides, and you get x equals to 12. Of course, it's not really x, but I'll just leave it as 12 and circle 12. All right, thanks for watching, everybody. Have a great day.